This is a practice problem number 2. A researcher wants to know the mean IQ of American kindergartners. He randomly selects 25 kindergartners and gives them an IQ test. The sample mean IQ is 102 and the sample variance is 196. Okay. Calculate the 95% confidence interval estimate of the population mean. Okay. So basically what it is this is the sample based on the sample distribution, sample data. This is the our estimate of the population distribution. We estimate that the mean would be 102 and variance is 196. Okay, what's 196? Sample variance is not 196. Okay. So based on the sample variance, we kind of estimate that the standard error would be 196 divided by 25. Actually, it's quite easy, because it's 513. Oh, wait a minute. Actually, 196, 169, 196. Okay, that's not it. Okay, so alright, if I do this calculation right, well, it's gonna be 2.8. Okay, so standard error is 2.8. Okay, and it's a t-distribution here, and the 0 to get 95% is 2 tail. 95% means it's 2.5%, and this is 2.5%. Oh, it's exactly the same way as the last one. So if I remember correctly, actually I don't remember correctly, so here, okay, it's 2 tails again, and degrees of freedom is, in this case, 24. So it's 2.064. Okay, 2.064. Okay, it's 2.064, and this is minus 2.064. The way I got this was degree of freedom was 25 minus 1 and 24. So I use the t-table to get these numbers. Okay, and then this is the standard deviation is 1. Okay, so everything is gonna be 2.8 times of this. Okay, so this distance is gonna be, okay, if I gonna get the 95%, these 2 points gonna be, okay, this distance is gonna be 2.8 times this, so 2.064, which is, okay, if I use my super duper fast brain, with oopsie, okay, I mean 2.8, so that would be 5.779. okay, that's gonna be the distance here, so which means, okay, this value for that point is 107.779, and that is, you know, oh, what did I do? And I can do a calculation like that, or I can just say, you know, I can just say okay, estimate population, okay, that would be 102 plus minus 5.779. I can also say that. Calculate 90% confidence interval estimate of population mean IQ. Okay, it's not that difficult, because this time we're still talking about the same population distribution. You know, mean was, we're supposing the mean is 102, and this time, okay, 90% confidence interval estimate is, you know, we are talking about all the means within this region, and this time it's 90%. So in other words, this is 5% and this is 5%. Okay, and we're trying to figure out, you know, these two numbers here, right? And again, we just want to know the distance here and here, and of course we can easily do it. If you know the math knowledge, basic math knowledge, you can do it, and using a t-distribution. Okay, and this is 90%, and again degree of freedom is 24 here. So if I use t-table, two tails and okay, combine, and this time 10% and 24, so it's here 1.711. okay, 1.711, so it's gonna be 1.711, and it's gonna be minus 1.711, and standard deviation is 1 again, of course. So standard error of the mean here, what was that? 2.8, was it? Was it 2.8? I can't remember. I'm gonna do it again then. Okay, so 196.25. Okay, 7 0.84. Okay, and the square root is 2.8. Oops, 2.8. Okay, so 2.8. So this distance is gonna be 1.71 times 2.8, and which is, okay, that's 4.79. Okay, so these 2 points are gonna be, okay, 102 plus 4.79 and 102 minus 4.79. So estimated population mean IQ is going to be 102 plus minus 4.79. That's the answer. Okay, problem question number 3. How do the 95 and 90% confidence intervals differ? How do they differ, you know? Okay. Oh, it's not, you know, when you compare two intervals, you know, the middle is same, right? It's the mean is supposed to be. It's talking about the same population, and the mean population mean is same. Estimated, you know, point estimate is 102, but 95% interval confidence interval means, okay, talking about all the means in this region, 95% and 90%. Okay, interval confidence interval means we're talking about only the means in this region. So how can I say, how do they differ, you know? 95% confidence interval is wider. This is wider. And this is narrower. Okay. In order to be more confident in general, we need to include a wider range of possible values of mu. So, you know, I don't know, that's what it is. Based on your answers to question 1, 2, and 3, would you expect a 99% confidence interval to be wider or narrower than 95? I don't know what it's talking about. You know, it's just so, I don't get the purpose of, you know, this question. Of course it's wider, and I don't know what it's asking. Okay.